I welcome all the students in the subject of computer graphics. Today we are going to learn the point which is related to filling area primitives. Okay, we are considering about how we can fill the different polygons or different areas. Under this, we are having the points, okay, the scan line polygon filling algorithm, then inside outside test, boundary fill algorithm, and clud fill algorithm. Okay, so today start our discussion, okay, with the scan line polygon filling algorithm. Our topic of discussion is polygon filling. Okay, now in the filled area primitives, okay, a standard primitive, okay, which is used for filling the area is a solid color, okay, or in maximum cases it is considered as a pattern polygon area. Okay, so whenever we consider about filling the area primitives or filling the area or any object, okay, when you are going to fill any object, we are always considered it as a polygon. Okay, the object we are considered as a polygon because polygons are easier to process, okay, as they are having the linear boundaries. Okay, so the algorithm that we are going to discuss or the technique that we are going to discuss all considered or all comes under the polygon filling. Okay, so that's why the name of the topic that we have written is polygon filling algorithm. Okay, we consider it as a polygon filling. There are the two basic approaches to area filling. So we are having, there are the two methods or approaches whenever I want to fill the area. Okay, which are these two approaches? The one way to fill an area is to determine the overlap intervals of a scan line. Okay, so we are going to fill the area by determining the overlap intervals of the scan line that crosses that particular area, that crosses the area. This approach is known as scan line approach. Okay, this approach of filling the polygon is known as scan line approach. Okay, so this scan line approach is generally used in general graphics packages, okay, to fill the polygon, circle, ellipse, curves. Okay, so all these are filled with the help of this particular method, scan line approach, and it is used in, generally it is used in all the graphics packages. So maximum graphics packages uses our method of scan line approach or scan line conversion. Okay, scan line method to fill that particular polygon. Okay, now there is another method also there, that another method for area filling is to start from a given interior position. Okay, so to start from a given interior position and pent outward from this point until we encounter the specified boundary region. Okay, so in the second method, generally it is also known as boundary fill. Okay, as we have considered here scan line fill, this is also known as the boundary fill algorithms. Now this method, what it does is, it considers that we are having or given the interior position, given a pixel which is inside that particular area to fill, we just goes on painting it outward from that point until we encounter the boundary region. Okay, so generally this also comes under the boundary fill algorithm, and this comes under the scan line filling algorithm. Okay, now to understand the general discussion and just consider here, okay, suppose I am having a triangle. Okay, I just consider it as one of the examples. Suppose I'm having this triangle as my polygon. My polygon is a simple triangle. Okay, now suppose I want to fill this triangle, okay, using my first method of scan line approach. What I will do, I will just consider every scan line which is passes this particular object. Okay, suppose these are the different scan lines. Okay, so if I consider all the scan lines, okay, and scan line, now it intersect here, so I consider intersection point of the scan line with the edges and just goes on filling this particular pixels on the scan line, then this approach is known as scan line approach. Getting me? Whereas my second method, okay, I just again draw one more triangle here. Okay, I'm drawing one more triangle, and in my second method is boundary region. Suppose I know the interior pixel. Okay, suppose I know that this is my pixel which is inside the triangle. Okay, so I call it as, here that is the written, given the interior position and given I know that any one pixel inside that triangle, after knowing this pixel I just goes on filling this color until I reaches to the boundary. So considering that pixel I just goes on filling it until I reaches to the boundary, then it is known as the second method. Okay, so if I use scan line, it is a scan line approach. If I use the any one pixel inside the region and then goes on filling it by considering that pixel I just goes on filling till the boundary, then it is known as boundary fill algorithm. Okay, so these are the two approaches that we are having for polygon filling algorithm. Okay, now this method, as we have said, this method is generally our first method of scanline approach is used in general graphics packages. Okay, now these methods starting from interior pointer are useful with more complex boundaries and in interactive painting system. So in interactive painting system and this, all these methods are, I say that they are more useful. Okay, so let us move to our discussion, continue our discussion of the polygon filling. Okay, and now we focus on the scan line polygon filling. Okay, that's why I have written this point as scan line polygon filling algorithm. This is also known as scan converting polygon. Okay, this particular point is also known as scan converting polygon. Okay, now we consider what is this scan converting polygon. For each scan line, I think this word is, you can find this word is used everywhere. Okay, for each scan line crossing a polygon, the area fill algorithm locates the intersection point. Okay, it is going to locate the intersection point of the scan line with the polygon edges. Okay, with the polygon edges. Now the intersection points are then sorted. Okay, suppose it is there are 3 intersection point or 4 intersection points. So these intersection points are then sorted from left to right. Okay, we are going to sort it from the left to right, and the corresponding frame buffer position between each intersection points are set to specified fill color. Okay, so this is what we are doing. Okay, just look at the diagram that we are having to understand the things in detail. Okay, so you can find that the diagram that we are having is, it is interior pixel along a scan line passing through polygon area. Okay, now you are knowing that this is my x direction, this is my y direction. Okay, and this is my polygon, this is my polygon. Okay, my polygon is this. No issue. Now what we are considering, which approach we are using, we are using scan line polygon filling approach, or we are using scan converting polygon. Okay, now suppose this is my scan line. Okay, you can find this blue line is my scan line. Okay, so my scan line is this. Okay, I show that this is my scan line. Okay, now on this scan line you can find this is my first intersection point of the scan line. Okay, this is first intersection of the point. This is my, which is intersected at what value? Intersection point is, first intersection is 10, second intersection point is 14. Getting me? Third intersection point is 18, fourth intersection point is 24. So this scan line intersect at these 4 points. Getting me? And now after knowing this, okay, what we are going to do, we know that this portion will be inside, 10 to 14 is inside, so we will start filling it with the color, whereas 14 to 18 is outside, so we should not fill it with the color, and 18 to 24, so this is filled with the color, this is outside, not filled with the color. This is again from 18 to 24 is inside, again it is filled with the color. Okay, I think this will clearly explain you how we are working for the scan line by scan line polygon filling algorithm. Okay, so the same description is continued here. Okay, so we just considered just now whatever we have discussed, it is written for your information, and shown in the diagram the 4 pixel intersection positions with the polygon boundaries define 2 set of interior pixel. It is going to define a 2 set of interior pixel. There are the 4 intersection points, x is equal to 10, x is equal to 14, x is equal to 18, and x is equal to 24. Okay, so these are the 4 intersection point that we are having. Okay, now what is my first region of intersection or interior position, rather I say, x is equal to 10 to x is equal to 14. You can find this, x is equal to 10 to x is equal to 14. This is interior region, so obviously it is filled with the color. Second region I am having, which is interior. Inside the polygon is x is equal to 18 to x is equal to 24. You can find it here, x is equal to 18 to x is equal to 24. Getting me? So these are the regions. So with the help of scan line, we are finding the region which are inside and the region which are outside this. Okay. So now we are considering one more example. I just move to the next slide. Just show you one more example of the scan line. Okay. Now again, under scan converting polygon, consider the polygon as shown in the diagram. Okay. So now just for a better understanding, we have considered this as another polygon value or another type of the polygon. Okay. Here you can find this polygon is defined with the number of edges. So I have connected these vertices of the polygon P1 and P2. This is my one edge. You can find this is one edge of the polygon. P2 and P3 is another edge of the polygon. P3 and P4 is next edge. P4 and P5 is the another edge. P5 and P1. Okay, so I call these are the edges of the polygon, and P1, P2, P3, P4, P5, these are the vertices of the polygon. Okay, now just to understand this, okay, we consider only two scan line examples. Okay, so suppose I considered now in the diagram scan line number 2. So I'm considering scan line number 2. See, this is my scan line number 2. Okay, this is the scan line number 2. Getting me? Now this scan line number 2 intersect the polygon at x value. Oh, what is this value? Oh, this value is x is equal to 1. Okay, so this scan line 2 intersect the polygon at x is equal to 1 and x is equal to 8. Okay, you can find here. The second intersection point is this. Okay, and we are having the value x is equal to 8. Getting me? So this scan line number 2 is having two intersection points. Okay, now as it's having two intersection points, these intersections are divided, or it has divided the scan line into three regions. Okay, so after this intersection point, we have to divide it into the region. Okay, what is my first region? My first region is x value less than 1 is outside the polygon. Okay, because whatever is there before this 1, it is outside, so it is filled with the background color, or rather we are not going to fill that particular color. Getting me? Then I am having the value x is equal to, x is between 1 to 8. Okay, so this particular area, getting me? This particular area x is equal to 1 to 8. Okay, that is inside of the polygon, so it is filled with the color. It should be filled with the color. Getting me? And whereas x is greater than 8, so all the things which are lies where x is greater than 8, okay, they are outside the polygon, so there is no need for us to fill this with the color. Getting me? So these are the this is the way that we will work for all the scan lines. We find out the intersection point, then we are going to divide it into the different region, whether the region is inside, whether the region is outside, and then we are going to fill this with the color. Okay, so one more scan line, just consider as an example. Similarly, scan line number 4. Okay, suppose now if I considered my scan line number 4, this is my scan line now. This scan line number 4. Okay, for this scan line, how many intersection point we are having? We are having the scan line number point, intersection point 1, this is 2, this is 3, this is 4. This scan line is having 4 intersection point. Okay, and now this is going to divide it into 5 regions. Okay, you can easily find that the number of regions are x is less than 1, it is outside in this part. Okay, this particular part is outside. Okay, so that is not filled with the color, it is background color. Second is x is equal to 1 to 4. You can find the next region is this. This is x is equal to 1 to 4. This is filled with the, obviously it is inside, so it is filled with the color. X is from 1 to 4 is inside, filled with the color. X is equal to 4 to 6. I think you can find this point. X is equal to 1 to 1, x is equal to 4 to 6, means I'm talking about this particular area. Okay, this one, this point to this point, this is outside the polygon. Getting me? X is between 4 to 6 outside the polygon, and again x is equal to 6 to 8. You can find from 6 to 8 this particular area, this particular region, rather say, it is inside. Okay, if it is inside, it is filled with the polygon color, and x is greater than 8. Okay, so it is outside the polygon. Okay, so here it is anything it is greater than 8 here, or all these things will be outside the polygon, and that is not filled with the color. Okay, I hope so all of you understood, okay, how we are working is scan line by scan line. Okay, so we are working with this, okay, and how we are in a position to use the scanline polygon filling algorithm. All the scanline polygon filling algorithm works on this particular method. Okay, find out the scan line, find out the intersection point, then find out the regions which are inside, which are outside, and fill it appropriately. Okay, so just now I continue with the discussion, and I'm moving to the next slide. Okay, we are continuing with the discussion of this. Now, there are some cases, okay, I can call it as there are some special cases are there that we have to consider. So that's why I have written here. Scan converting some scan line intersections at polygon. Some scan lines are intersecting at polygon vertices, and we required a special handling. Okay, so just to understand that in depth, if such cases are there, that we have to take care. Okay, because these scan lines are intersecting the polygon vertices at the exact point or vertices point, so we required a special handling of this. A scan line passing through a vertex, okay, intersect two polygon edges at that position, adding 2 points to the list of intersection for the scan line. Okay, now if I consider, you just check at that, this is scan line number y dash. Okay, so I want everyone to look at the diagram. In the diagram, you can find this is the scan line y dash. Okay, this scan line. You can find this is my first intersection point of the scan line. One is written. Now this is the second intersection point. Now this second intersection point is important because it is exactly intersecting the polygon vertex. Okay, this polygon vertex. Okay, so it is exactly intersecting to this. Now the question comes is whether to activate this or not. Okay, because some part is lies outside the polygon, we should not activate. If maximum part is covered inside, then we have to activate. Okay, I think we have seen this in anti-aliasing. Okay, so that's why we have written such cases should we have a special handling, or we should take care. And then again I am having the next one, and so on, scan line number y dash. Okay, now this 1 1 means it is normal intersection point. 1 1 means it is normal intersection point, but this to indicate that it is going to intersect with the exact vertex. Okay, all exact vertices. Okay, so that is what written here, intersection points along scan line that intersect polygon vertices. Scan line y generates an odd number of intersections. Okay, y generate odd number of intersection, but scan line y dash generate an even number of intersection that can be paired to identify correctly the interior pixel span. Okay, so see, if I consider in between this to this, okay, at this side I consider it may be filled with the color. Okay, and this to this, if I consider it should be filled with the color again. But the question is, what about this particular point, second point? Shall we have to activate it or not? So that's why we have to take care. Okay, if I consider scan line number y, you can find it is intersect at this point. No problem with the intersection point. It will now here. It intersect, second intersection point is it is intersecting to the vertex directly. Okay, the actual point. Then we are having the next intersection point, no issue with this. Again, there is no issue with this. Okay, because it is not intersecting directly to the vertices. Okay, so that is the point we have written here. Just to understand, such cases should be handled. That you can find as shown below, two scan lines at position y and y dash that intersect edge endpoints. Okay, endpoint of the edges. So that is what we have considered. This is the endpoint of the edge of this edge as well as this edge. Okay, this is the end point of again the two edges, this edge and this edge. So this is are the end points of the edges, and that should be handled appropriately. Okay, so that's why I have added this slide, so that we should understand if it is the case. Now again I have already told the solution. Okay, what is the solution for this particular point? What we have seen already in the anti-aliasing method, if maximum part of this pixel is inside the polygon, we should fill it with the color. Okay, and means suppose I am having more than 50 or 70-80% parts is inside the polygon, fill it with the color. If it is not inside the polygon, or there is only 10 or 20% part inside, maximum 80% part is outside the polygon, then I think we should not fill this with the color. Okay, so that is what we are considering. Okay, so let us move to our continue our discussion and moving to the next part. Now here what we are going to do, okay, now why we are having this point of discussion, why I have added this, okay. Now I am considering now the first algorithm which is come under the scan converting polygon, or which uses the scan line approach, okay. So there are multiple algorithms are there. We are having the edge fill algorithm, then we are having fence fill algorithm, we are having edge track fill algorithm, okay. But now we are considering the first one, which is called as the edge fill algorithm, okay. Now while considering this algorithm, okay, so I'm not going directly to the algorithm, but before that I want to make one more thing clear to everyone, that is we are considering here, okay, for more accurate result we uses the half scan line convention, okay. See, what is my point of discussion is, now whatever the scan line convention we are using, but it is not appropriate, but we have to use half scan line convention as shown below, okay. Now that's why I'm having this slide for you to understand. Now see, in the diagram number A, okay, so you can find that suppose this is my scan line 1, okay. Now what is my pixel boundary? Now this is my pixel, everyone knows that this is my pixel. Where the pixel is addressed, pixel is always addressed at the center, okay. Now again this is my next pixel, okay, you can find. And what is my scan line? This is my scan line, my scan line number 1, this is my scan line number 2, this is my scan line number 3. Suppose I take the example of this center pixel or any one pixel, this pixel, okay, and the pixel is addressed at the center, so the center of the pixel is considered to the accurate point of intersection. But now the scan line number 2 and scan line number 3 both are intersecting this pixel boundaries, okay. This is my pixel, and though it is a square or the grid, the actual pixel is activated as a circle, okay. Everyone knows that actually it is activated as a circular fashion, or it is activated as a circle, getting me, okay. Now for this particular purpose, if I use this scan line, then I will not get correct intersection point. So what is the solution is, use half scan line convention. We have to use actually half scan line convention, means though I am saying that it is scan line 1, but actually it is scan line 1.5, okay. Always remember, though I say it is scan line 1, it is actually scan line number 1.5, because you can find that this particular scan line is now exactly intersecting all the pixel at their center, okay. So that's why we are having this point of discussion. For the accurate result, what we have to do is we have to consider the half scan line convention. So scan line number 2 means it is not actually 2, it is scan line number 2.5, scan line number 3.5, scan line number 0 means it is actually 0.5, okay. So these are the ways, or these are the things that we are considering in all the scan line algorithms, so that we should get the accurate result, okay. So because if I consider scan line number 4 here, okay, it is accurately, it is having some other part, okay. So what I have to consider, it is not 4, it is 4.5, okay. And if the 4.1 is not intersecting my area, I think we should not consider it, okay. And in this particular case, that I'm not using scan line convention, unfortunately some extra area is also filled with the color, okay, and generally we don't want it, okay. So that is the reason, always remember, though I say it is scan line number 1, it is actually scan line number 1.5, okay, and that is called as half scan line convention, okay, which is used in the algorithm, okay. I hope so of you cleared with this point, okay. Now I think we are in a position to move to the actual algorithm, okay. So now we are moving to the what is edge fill algorithm and how it is fills the polygon, okay. So why we are considering one algorithm, because this comes under the scan converting polygon, or it comes under the scan line approach of the polygon filling, okay, getting me, okay. So let us move to our next slide to understand edge fill algorithm in detail, okay. Yes, now you can find that this is the algorithm, edge fill algorithm. I think the algorithm description is very simple, okay. It is have only one sentence or the statement, What is the edge fill algorithm? For each scan line, that is what I told. Okay, so whenever I'm using this scan conversion polygon, this word is always there for each scan line, because I have to consider all the scan line which are intersecting my polygon, okay, or polygon edges. Okay, so this is written here for each scan line intersecting a polygon edge at the point x1 comma y1. Okay, so each scan line intersecting the polygon edge at x1 comma y1, what we have to do, we have to complement. Okay, this word is very important. What we have to do, we have to complement all pixels, okay, whose midpoint lies to the right of x1 comma y1, that is for x comma y1. I think we are having adding the 0.5 here. X plus 0.5 is greater than x1. Okay, so if I add 0.5, it should be greater than it, and it should is lies to the right of the point. Okay, so here I'm just considering, suppose this is the pixel. Okay, this is the intersection point, then this is considered to be your right side of the pixel. This is R. Okay, I just write it as R means right side, and this side we consider as the L, left side of the pixel. Okay, this is left side and this is the right side. So we have to activate all the pixel which are lies to the right of the or right side of the pixel or intersection point rather, I say. Now what is mean by this complement? Okay, what is mean by complement all the pixels? Getting me? Now the complement means, suppose this is the pixel. This pixel is already filled with the background color. Okay, inside this it is white color. It is background color. Then complement means it is already filled. It is already with the background color. We have to fill this with the color. Okay, so I am filling this with the color. Getting me? Now if it is already filled with the color, see what I'm saying. If the pixel is already filled with the color, we have to complement it, means we have to set it to the background. Okay, I need to remove this. Okay, I need to remove this color, and I will set the pixel back to the background. Okay, as a white color. Okay, and this is what the meaning of we can say complement all the pixel for each scan line intersecting a polygon edge at x1 comma y1, complement all the pixel whose midpoint lies to the right of the x1 y1. Getting me? Now what we have to do, what we are going to do is, let us consider this with the help of the diagram. Okay, or one example. Okay, so I just checked whether we are having, yes, we are having this diagram. So I want everyone to concentrate on the diagram or the polygon, so that you will understand step by step how this polygon, how this edge fill algorithm works. Okay, this is my original polygon or this is my first polygon. I think just now we have seen this as an example, p1 p2. Okay, look at this diagram first. Okay, first diagram, P1, P2, age P2, P3, P3, P4, P4, P5, and P5, P1. Okay. Now what I have to consider? I have to consider the algorithm by every age. Okay, every polygon age. I have to consider every polygon age. So what is my first age? My first is P1 to P2. This is my first age, P1 and P2. Okay, now by considering half scan line convention, my first scan line will be 0.5, 1.5, 2.5, and I found that no scan line is intersecting the P1 and P2. If you always remember, no scan line is intersecting the edge if it is a horizontal edge. If my edge is horizontal line, my edge is exactly horizontal line, then the scan line is not intersecting with this, so there is no need to consider anything, no need to do anything. Okay, so no need to do anything for the first age P1 and P2. Let us go to the next age. What is my next age? P2, P3. See, this is my next age is P2 and P3. So that is what's shown here. Consider now, just consider this diagram. Okay, consider the diagram number 2. Which age we are considering? We are considering age P2 and P3. What I have to do now? All these are my intersection points. Getting me? Intersection of scan line with the age P2 and P3. All these are my intersection points. Okay, what I have to do for each scan line intersecting the polygon edge at x1 y1, complement all pixel whose midpoint lies to the right of the x1 comma y1. Getting me? So whose midpoint lies to the right side. Okay, right side of this. So what I have to do here, or what I have to do in this particular case is, all the points which are lies, which are moving to this side, I have to complement this to this to this, all this. All these points I have to complement. Complement means what? These are already set with the background color, so we have to set it to the polygon color. You can find it here. Okay, all these pixels are filled with the color. Okay, polygon filling color. Okay, all of you get it? Yes, this is the edge P2 and P3. All the pixel which are lies to the right side, okay, or filled with the color. Getting me? Now moving to the edge P3 and P4. Okay, now I am moving to the edge P3 and P4. This edge. Okay, now I am considering in the previous diagram, and this is the updated diagram now. Okay, now for this particular edge, you can find these are the pixels, okay, which are not filled with the color. What is the scope of this scan line? This up to this. Okay, this is filled with the color. No, it is background color, so I have to complement it. So this is filled with the color. You can find this area is now filled with the polygon color, and this is the area, okay, which is already filled with the color. So it is complement. Already filled with the color, it is complement. It is set to the background color. You can find that this particular area is now set to the background color. Okay, here it is already filled. Complement means fill it with the background color. This area is not filled with the color, so it is filled with the polygon color. Getting me? So this is what the convention that we are having. Now after this edge, I have to move to the next edge. Okay, what is my next edge is? My next edge is P4 comma P5. My next edge is P4 comma P5. Means I am considering now this edge. Okay, now I am considering this particular edge, and the results are shown in this diagram. Results of the same are shown in this particular diagram. Okay, now look at this particular edge. For this edge, what is the scope of this edge? From this side to this side. Okay, this is the scope of the all pixel which are lies at the right of the intersection point. See, these are my intersection points of this edge. Getting me? Okay, now I hope all of you have cleared with this. Now you can find this much area, this one, this, and this. What is the color of this? It is background color. So all these pixels are set with the polygon color. Getting me? So that is what happened here. You can find it here. All these areas are filled with the polygon color. Okay. Whereas this particular area, look at this. This area is already filled with the color. So I have to complement it. Complement it. It is now filled with the background color. You can find it here. This is already filled with the color. So now in the next this diagram, it is filled with the background color. Getting me? So this is filled with the background. Okay. So now after that, I think only one edge is remaining now for our discussion. So now we have to concentrate on this particular edge. Okay, we are considering this as a this particular edge, that is the last edge that we are considering. Okay. Now again, the answer is given here in this particular diagram. Okay, but now I will consider for explanation the previous diagram. Okay, this edge. Now for this edge, you can find which is already filled with the everything which is already filled with the. Now you can find here, okay, this particular part, this is already filled with the color. Okay, means somewhere I am having this area which is already filled with the color. You can find here, it is already filled with the color. Okay, this is also filled with the color. Okay, so all this part which is already filled with the color is complement, means it is set to background color. Okay, so all this area is set to the background color, and how you can find this particular area, complete area of the polygon is set to the polygon color. So I'm going to set this particular area with the polygon color, and at the end, after considering, after examining all the edges of the polygon, you can find in the last diagram or this particular diagram, the polygon is filled with the given color. You can find the polygon is correctly filled with the given color. Getting me? So this is what the thing that we are considering in the scan line conversion or scan converting polygon or scan line polygon filling algorithm. Okay, so that is what I say. The algorithm is edge fill algorithm. Similarly, we are having the algorithm, updated algorithm of edge fill. We are having fence fill algorithm. Then we are also having edge flag fill algorithm. Okay, to be considered. Okay, which are comes under the scan converting polygon or scan line filling algorithm. Okay, now just now I think I hope all of you understood it very easily. Okay, so now I just moving to one more slide. Okay, to understand which are the advantage and disadvantage of this algorithm. Okay, is there any problem with this particular algorithm? Okay, so just now I am moving to the next slide, last slide of the discussion, age field algorithm. You can find these are the advantages. Okay, so what is the advantage is the age field algorithm is very simple. Okay, you can find that it is just a sentence and it is very simple, okay, to understand. Rather say I very simple to understand. Okay, very simple to understand or to use. I think that understanding word is very important, because why I'm saying this forcing to the understand, because it is difficult to implement. Okay, that is a drawback. Okay, it is very easy, or it is very easy to understand. Understanding of the algorithm is very easy. Okay, that was our point of discussion. Okay, the algorithm is most efficiently used with the frame buffer. So wherever I am using the frame buffer method, this algorithm is very easy to or most efficiently used with the help of the frame buffer. These are the two advantages of the age field algorithm. Okay, but now which are the disadvantages? So what is the main disadvantage of this algorithm is, for more complex picture, okay, the picture is more complex, my polygon is more complex, what is going to happen? Each individual pixel is addressed many times. Okay, so just understand this word. Each pixel is addressed many times, with the same pixel is visited more number of times. Okay, therefore it is time consuming. So this algorithm is time consuming, and also the algorithm is limited by the input output consideration. Algorithm is limited by input output consideration. See, when I am going to activate one pixel, means it is my input output operation, IO operation. Okay, because I have to activate that pixel with the color. First time I will activate with the polygon color, again I will activate it with the background color. Okay, again I will activate it with the polygon color, and so on. Okay, so that's why we are considering this as the main disadvantage. Okay, so that is what I have written. Individual pixel is addressed many times means what? One pixel is activated, that is set to polygon color, and deactivated. Okay, activated and deactivated, the same pixel is activated and deactivated more number of times. Okay, so activated means it is set to polygon color, and deactivated means it is set to background color many number of times. Okay, and this is what the drawback, main drawback of age field algorithm. Okay, so we can find, okay, with another example, as I'm just explaining you one of the example, very simple example of a triangle, how it is filled with the age field algorithm. Okay, now for all this algorithm, I think one more important thing we should understand, we should know what is my bounding box, or what I must consider this is my screen. Okay, okay, I'm just showing you one more example to understand the drawback. Okay, now this is, you can consider my triangle. I'm just taking a very simple example of a triangle here. Okay, now what is my first edge? My first edge is this. Okay, now I'm considering, suppose this is P1, P2 and P3, only 3 points are there. Now is there any change for edge P1 and P2? Okay, suppose I consider this is my edge P1. Okay, this is my edge P2. Okay, and this is my edge P3. Okay, P1, P2, for the edge P1 and P2, there is nothing is required, because it is a horizontal edge. It is not intersecting any scan line. Okay, but now next, which I am going to consider, I am going to consider P2 and P3. Getting me? I am going to consider P2 and P3. So for P2 and P3, what I have to do? Suppose I have to fill this with the brown color. Okay, whatever my pen color is there, I want to fill it. Okay, so all the pixel intersecting this point, so these are my all intersection point, all the pixels which are lies to the right of this, I have to fill it with the color. So in my step number 1, what I am going to do is, I am going to fill this with the color. Okay, what I have to do, I have to fill this with the color. Okay, for the age P2 and P3. Getting me? I think it is understood to you. Now again, I consider my next diagram. In my next diagram, okay, what we are having is, in my next diagram, I will consider now age P1 and P3. I have to consider this age P1 and P3. You can find for the age P1 and P3, this is the scope. This is the scope of the age. Getting me? For this particular case, whether this particular complete part inside the triangle, this part is not filled with the color, so obviously what we are going to do, this will be filled with the color. This particular part is filled with the color, getting me? So this is filled with the color, and this particular part is already filled with the color, so it is set to background. Okay, it is set to background. So only in 2 steps I will get my polygon is filled with the color. But what is the problem in this case? What is the drawback is, look at this pixel, all these pixels are visited 2 times. How many times? It is visited 2 times, because first it is set to the polygon color, step number 2 it is all these pixels are set to the background color again, getting me? So I'm going to consider this is, or these are, this is what the drawback of edge fill algorithm. Okay, but this scanline method, whatever we have discussed, okay, with some improvement, okay, in the next versions of the algorithm it is improved, and it is generally used in all graphics packages. Okay, maximum graphics package uses the scanline conversion because it is most efficiently used with the frame buffer, and maximum time we consider our display is a raster scan display. Getting me? I hope so all of you understood today's session, where we have started learning what is meant by the polygon filling algorithm. We have seen there are the 2 approaches. One is scanline approach and second is boundary fill approach. Getting me? And we have worked on the, today we have learned our discussion, or we have learned in detail how this scanline polygon filling algorithm works. Okay, what is meant by the scanline, how to find out intersection point, divide it into the region which are inside and outside, and then fill it appropriately. Okay, so this is what we have learned today. Okay, so in the next session, okay, we are going to consider the inside outside test, or okay, the algorithm related to this, and then we will move to the boundary fill algorithm or seed fill algorithm. Okay, thank you all.